Welcome to Quasar, Galactic Observatory, where TON 618 turns size itself into tonight's deepest astronomical mystery. Before explanation begins, the universe offers a distant blaze so oversized that proportion already starts slipping away. TON 618 is so vast that familiar measurements fail first, and intuition collapses before comprehension even begins. We first meet this darkness through astonishing brightness as violent light announces what no eye can see. What dominates the scene is the Quasar engine, where plunging matter converts gravity into overwhelming radiance. The deeper we look, the less TON 618 resembles an object, and the more it resembles infrastructure. Tens of billions of solar masses sound precise, yet the numbers remain sterile until scale becomes imaginable. Its event horizon is shocking, because mass here creates a boundary so immense that size becomes physical. With a black hole this huge, crossing the horizon may begin quietly, even as escape ends forever. The invisible center stays dark, but the accretion disk speaks loudly enough for the whole cosmos. Once spectacle fades, the harder question emerges. How does anything grow this large before conditions intervene? Simple accumulation sounds plausible, yet early cosmic time leaves black holes becoming enormous with unsettling speed. The mystery sharpens further when growth itself starts resisting the feeder that seems built to continue. Radiation turbulence and feedback push outward so fiercely that feeding becomes a struggle against self-created limits. TON 618 also rules its galaxy, shaping gas stars and future structure far beyond the center. Every comparison begins failing beside it, exposing less about TON 618 than about our scaling language. At the edge of such magnitude, description gives way to a harsher question about law itself. Here, matter, light, time, and information enter one of relativity's most punishing and revealing environments. TON 618 is more than spectacle. It preserves clues about how the young universe built power. In the end, large becomes too weak a word, and understanding begins only after comparison fails. If this scale has pulled you in, like, subscribe, and thank you for listening. Now enter part 1. Mercury should be easy to explain. It is the smallest planet, the closest to the Sun, and the fastest thing in the planetary family. From a distance, that sounds like a complete summary. But Mercury only looks simple because most of what defines it is invisible at first glance. The real story is not that it races around the Sun in 88 days, or that it appears briefly in twilight and then vanishes. The real story is that Mercury is a world left frighteningly exposed, a planet that seems to have been built without protection and then forced to survive where protection matters most. It is not merely near the Sun. It lives under conditions that turn every weakness into a permanent geological sentence. That is why this small dark sphere becomes one of the most violent objects in the inner solar system without needing giant storms or oceans or rings. Its extremity is quieter than that. It is written into the structure of the planet itself. The obvious explanation is heat. Mercury is close to the Sun, so of course it is scorched. That explanation is true, but it is too small. Heat is only the surface version of the problem. Beneath it sits a harder truth. Mercury is a planet that seems to have lost too much too early and then spent 4.5 billion years enduring the consequences. Even its name points in the wrong direction. Mercury, messenger of the Roman gods, suggests speed and agility. The ancient skywatchers noticed how swiftly it slipped through the dawn and evening sky, never straying far from the Sun, always difficult to hold. But speed is only what Earth sees. What Mercury itself reveals is damage. The planet is about 3,000 miles across, only a little larger than Earth's moon, yet it is astonishingly dense for its size. That density is not a minor detail. It is one of the first warnings that Mercury is not a normal small planet. Hidden inside this compact world is an enormous iron core taking up roughly 85% of the planet's radius. Earth has a large core too, but not like this. On Mercury, the metal interior dominates the whole body so thoroughly that the planet begins to look less like a balanced rocky world and more like a giant core wearing a thin shell of stone. A planet like that does not merely differ from Earth. It raises a deeper question. What happened to the rest of it? That question changes the frame. Mercury stops being a convenient first planet in a textbook diagram and becomes evidence of a much older crisis. Perhaps it forms in the early violence of the solar system, under conditions that allow metal-rich material to gather close to the Sun. Perhaps a colossal impact strips away much of its outer rocky layers. The details remain debated, but the pattern is clear enough to matter. Mercury carries the signature of loss. The story on the surface is a small world near a big star. The story underneath is a survivor that may once have been more complete than it is now. And that history governs everything. Mercury has only a very thin exosphere, not a thick atmosphere that can cushion incoming energy, circulate heat, drive weather, or shield the ground below. This is not a minor absence. It is the condition that defines the planet's daily life. On Earth, atmosphere softens extremes, spreads warmth, moves clouds, carries water, and turns raw solar input into climate. On Mercury, there is almost nothing to moderate anything. Daylight can drive surface temperatures to around 800 degrees Fahrenheit. Night can plunge toward 290 degrees below zero. Those numbers sound like trivia until their meaning becomes visible. A planet without protective air does not merely get hot and cold. It becomes defenseless. It cannot hold heat. It cannot hide from radiation, solar wind, or impact. It takes the sun directly. Charged particles strike its surface. Atoms are blasted loose. Sodium, oxygen, hydrogen, helium, and potassium drift in a ghostly envelope so thin that calling it an atmosphere almost misleads. The planet is not wrapped. It is exposed. And yet Mercury does not simply sit there and suffer. It records. Its surface preserves the evidence with brutal honesty. Because there is almost no weather and no active plate tectonic system like Earth's, to recycle the crust scars remain. Impact basins remain. Craters remain. Long cliffs remain. Mercury looks wounded, because in a meaningful sense it is. But even those wounds are not only about bombardment from outside. Some are signs of change from within. As its enormous metal core cools over immense spans of time, it contracts. The planet shrinks with it. The crust is forced inward. Faults form. A world that already looks ancient and battered turns out to have been slowly tightening around itself for billions of years. This is the real Mercury, not just hot, not just fast, not just close, but compressed, stripped, and left to endure. Even its magnetic field, weak but real, complicates the picture. Mercury should feel dead in the easy sense of that word, a small planet long cooled and finished. Instead, it still carries signs that its interior is not fully simple, not fully silent, not fully done. A tiny world should be geologically trivial. Mercury refuses that role. Because it is hard to observe from Earth, always lurking near the sun's glare, it is easy to neglect. But that neglect hides one of the harshest planetary case studies in the solar system. Mercury is what a rocky world looks like when shelter is stripped away and the environment keeps collecting the debt. The planet's speed is real. Its closeness is real. Its heat is real. But those are only the visible edges of a deeper fact. Mercury is not simply the first planet from the Sun. It is a record of what exposure does to a world over billions of years. And once that becomes the frame, the next question is no longer why Mercury moves so fast. It is how a planet this damaged ends up built this way in the first place. Mercury is close to the Sun, but closeness is not the whole explanation. That sounds obvious until you try to account for the planet honestly. Distance can explain why sunlight is stronger there. It can explain why the Sun looks larger, why the planet moves at an average speed above 100,000 miles per hour, and why the dayside can become blisteringly hot. But once those first facts are stated, the easy version of the story begins to fail. Nearness explains the punishment Mercury receives. It does not fully explain the kind of world Mercury is. The distinction matters. Many people imagine the innermost planet as a simple result of solar heat, as though Mercury is just a rocky object baked harder than the others, because it forms too near the furnace. Yet heat alone does not build a planet with such an enormous iron core, such unusual density, such long global scarps, and such a strange combination of weakness and persistence. The Sun shapes Mercury relentlessly. But the Sun does not explain everything the planet has become. To see why, it helps to look at what proximity actually does. Mercury orbits at an average distance of roughly 36 million miles from the Sun, far closer than Earth's 93 million miles. Because sunlight falls off dramatically with distance, that difference is not modest in practice. It is transformational. Mercury receives several times more solar energy per unit area than Earth does. And yet, even that fact can mislead, because the planet does not behave like a place wrapped in searing weather. There are no cloud decks glowing above a pressure-cooked sky, no thick atmosphere trapping heat in the Venusian sense, no global winds redistributing energy from day to night. Instead, Mercury faces the Sun with almost nothing between rock and radiation. That is why it becomes a planet of violent contrast, rather than one of continuous thermal oppression. The ground in sunlight can soar to around 800 degrees Fahrenheit. Then the long darkness drags the temperature downward into a cold deep enough to shatter any easy intuition about what closest to the Sun should mean. The real problem is not just incoming heat. It is the absence of a system capable of managing it. On Earth, air and water transport energy. On Venus, a thick atmosphere traps it. On Mercury, almost none of that machinery exists. The planet is close to the source, but structurally unequipped to soften the blow. That helps explain the extremes. It does not explain the design. Mercury's orbit itself adds another layer of stress. It is not a perfect circle, but an ellipse, meaning the planet moves through varying solar conditions as it sweeps around the Sun. It speeds up as it draws nearer and slows as it moves farther away, and this changing pace contributes to one of the odder rhythms in the solar system. Mercury rotates slowly while orbiting quickly locked in a 3-to-2 spin-orbit resonance, turning 3 times on its axis for every 2 trips around the Sun. The result is not a simple daily cycle like Earth's, but a more complicated relationship between sunlight surface heating and time. A solar day on Mercury lasts 176 Earth days, twice as long as the Mercurian year. This is the kind of detail that sounds technical until its meaning becomes visible. On Mercury, exposure is prolonged. Daylight lingers. Darkness settles in for immense stretches. The planet is not just close to the Sun. It is forced into a strange temporal arrangement with it. And still, even this deeper orbital story remains incomplete. If Mercury were only a victim of solar intensity, the planet might be easier to understand. But the clues on and within Mercury point to something harsher than exposure alone. Its density is remarkably high for such a small world, and that immediately raises suspicion. A small, rocky planet ought not to be dominated so thoroughly by metal, unless something in its formation or early evolution departs from the ordinary pattern. The obvious explanation is that the inner solar system simply favored heavier material closer to the Sun. There is truth in that idea. But again, the simple answer is not the full one. Mercury appears too extreme, too metal-rich, too reduced. It looks less like a straightforward inner planet and more like a remnant. That word changes everything. A remnant is not merely formed. It is what is left after something else has been taken away. That possibility gives new meaning to Mercury's proximity. Being close to the Sun may have helped determine what raw materials were available. It may have increased energetic collisions in the early solar system. It may have made it harder to retain volatile compounds. But the planet's present form still seems to imply either extraordinary early sorting or extraordinary loss. In other words, Mercury is not just a world shaped by where it is. It may be a world defined by what it no longer has. That is a darker story. It turns Mercury from a simple first planet into a forensic object, a surviving fragment of early planetary violence. And once that possibility is allowed in, the entire picture shifts. The heat, the speed, the thin exosphere, and the brutal temperature swings all become secondary to a harder question. Was this planet always meant to be this way, or was it reduced to this state by catastrophe? The closer one looks, the less satisfying proximity becomes as a final answer. Closeness explains the environment. It does not fully explain the body enduring that environment. Something about Mercury feels incomplete, as if the planet stands in the solar system, not merely as the innermost world, but as the leftover core of a larger planetary story. And that is where the real investigation begins. Because to understand Mercury at all, it is no longer enough to ask what the Sun does to it now. The next question is, what kind of ancient damage could leave behind a planet like this in the first place? Mercury looks unfinished. That may be the most unsettling, truthful way to describe it. Not broken in a dramatic, cinematic sense. Not shattered into debris. Not visibly torn apart in a way the eye can instantly recognize. Instead, it looks like something that has survived a process that removed too much and then forced the remainder to persist. By the time scientists began measuring Mercury carefully, the planet was already giving off this impression. It is too dense for its size. Its metal core is too large to ignore. Its rocky exterior seems too thin relative to the body beneath it. The easy story would be that Mercury simply forms close to the Sun, where heavier materials gather, and that this naturally produces a metal-rich world. That idea still matters. It may even be part of the answer. But the more closely the numbers are examined, the less satisfying simplicity becomes. Mercury does not just look metal-rich, it looks reduced. The story on the surface is that it is the smallest planet. The story underneath is that it may be the remains of something once more complete. That is where the tone of the whole world changes. A planet can be small because it never becomes large, or it can be small because it loses what it once had. Those are not the same story at all. In the first case, Mercury is just a minor product of planetary assembly. In the second, it becomes evidence of ancient violence on a scale that reaches back to the earliest age of the solar system. This is why Mercury is no longer just a hot rock near the Sun. It is a forensic problem. The most famous version of that problem is the giant impact idea. In this picture, early Mercury begins as a more ordinary rocky planet with a larger mantle of silicate material surrounding its metal interior. Then, something catastrophic happens. A massive collision, perhaps with another large body in the young solar system, strikes Mercury hard enough to blast away much of its outer rocky layers, while leaving much of the iron-rich interior behind. The result would be a planet that looks very much like the one we see now, compact, dense, and dominated by metal. It is an arresting scenario because it explains Mercury not as a strange beginning, but as a brutal remainder. The planet becomes the surviving core of an ancient planetary assault. But even here, caution matters. The giant impact hypothesis is powerful, yet not simple in detail. Collisions that energetic can scatter debris widely, and one hard question follows immediately. If so much rocky material was blasted off, why did it not simply fall back together or reaccrete onto Mercury? Perhaps some of it was lost into the inner solar system. Perhaps repeated collisions helped strip the planet further. Perhaps the dynamics near the Sun made reaccretion less efficient than it would be farther out. The point is not that scientists have a single final answer. The point is that Mercury forces the question because its present form is difficult to accept as ordinary. Other explanations try to avoid the single catastrophic blow. Some models suggest Mercury may form from especially metal-rich building blocks in the hot inner region of the early solar system, where lighter silicate materials are less likely to dominate. Others explore whether intense solar radiation, drag in the young solar nebula, or high-temperature chemical sorting could preferentially remove or separate rock-forming material from metal before Mercury fully assembled. These ideas matter because they move the mystery from destruction to selection. Instead of asking what stripped Mercury down, they ask whether the planet was biased toward becoming metal-heavy from the start. But these theories carry their own burden. They have to explain not just why Mercury is dense, but why it is this dense, this extreme, and this distinctive among the terrestrial planets. Mercury is not merely a slightly adjusted inner world. It is a planetary outlier, and outliers demand either unusual origins or unusual histories, sometimes both. What makes this harder is that the event itself is long gone. No witness remains. No primordial debris field hangs nearby with a label attached. The early solar system was a violent workshop filled with collisions, migrations, heating, and rearrangement. Many worlds were altered. Some never survived. Mercury may be one of the few that still carries the shape of that era in a particularly exposed form. This is why the planet matters beyond its size. It compresses an entire chapter of planetary history into a single object. It asks whether worlds are primarily built by gradual assembly or whether some of them are defined more by what gets taken away. That distinction echoes far beyond Mercury. It touches the formation of rocky planets in general, the role of giant impacts in shaping worlds, and the possibility that planetary identity is sometimes created by loss rather than accumulation. And Mercury keeps reinforcing that frame. Its surface is ancient. Its crust is comparatively thin. Its overall density remains one of the strongest clues in planetary science that something unusual has happened. This is not just a place scorched by the sun. It is a place that may have been fundamentally edited before the long era of solar punishment even began. That possibility gives the planet a different emotional weight. Mercury becomes less like a blank little world at the edge of the sun's glare, and more like a survivor carrying the consequences of a forgotten wound. The obvious explanation is still proximity. The deeper explanation may be trauma. If that is true, then Mercury is not simply the closest planet. It is a world stripped closer to its own center than any of its neighbors. And once that possibility is accepted, the next layer of the story becomes unavoidable because the planet's oversized core is no longer just one feature among many. It becomes the buried force that governs almost everything Mercury is. Mercury's core is not a detail. It is the planet's real body. Everything else begins to look like a thin concession wrapped around it. That is what makes Mercury so hard to place alongside Earth, Venus, and Mars, as though the 4 terrestrial planets are simply variations on one design. They are not. Mercury belongs to the same rocky family, but it pushes the pattern into something more severe. On most worlds like this, the core matters because all cores matter. They help determine density, magnetic behavior, thermal history, and long-term internal evolution. On Mercury, the relationship is more radical. The core does not just influence the planet, it dominates it, with an iron-rich interior extending through roughly 85% of the planet's radius. Mercury is built in a way that makes its silicate mantle and crust feel comparatively slight, almost like leftovers after the main decision has already been made. The obvious explanation is composition. Mercury has a lot of metal. True, but that statement is far too flat for what the planet is actually revealing. The deeper truth is that Mercury's oversized core changes the scale of every other process acting on the world. It changes how the planet formed, how it cooled, how it shrank, how it recorded damage, and even how it resisted becoming completely inert. This is why the core has to be treated not as a hidden feature beneath the planet, but as the buried force that governs the whole system. Density offers the first clue. Mercury is small, but it is far denser than a body of its size ought to be if it were made mostly of lighter rocky material. Strip away the intuitive picture of a generic little planet, and what remains is something much stranger, a compact, metal-heavy world with the mass distribution of an object more severe than its appearance suggests. If Earth were reduced in size while keeping some balance between mantle and core, it would still not quite look like Mercury. The inner planet seems overcommitted to iron. That overcommitment is not merely a compositional curiosity. It is a historical fingerprint. It points backward to formation and loss, but it also points forward into every later chapter of Mercury's evolution. A large metal core stores heat differently from a shallower one. It cools over long spans. It contracts as it does. That contraction becomes geological fate. Mercury does not have to erupt dramatically or overturn itself in spectacular episodes to reveal its internal history. It only has to tighten. Over billions of years, the cooling interior pulls the planet inward. The crust, unable to simply vanish, buckles and breaks. Vast lobate scarps form across the surface, cliffs and ridges hundreds of miles long, in some cases where one section of crust is thrust over another. These are not local oddities. They are evidence that the entire planet has been responding to internal contraction. Mercury has shrunk radially by more than 4 miles over deep time. That number sounds modest until its meaning is understood. A whole world is drawing inward around a cooling metallic heart. The surface is not just old. It is being asked to absorb the consequences of a long internal retreat. This is where Mercury stops being just a cratered object near the Sun and becomes something more unsettling, a planet whose present shape still carries the slow after-effects of its own buried mass. The core also complicates the question of planetary death. Small worlds are supposed to cool fast. Their internal activity is expected to fade earlier than that of larger planets because they lose heat more efficiently. In one sense, Mercury does look old and quiet. It lacks Earth's plate tectonics. It lacks a thick atmosphere. It lacks the outward signs of a vigorous modern world. But the story does not end there. Mercury still has a global magnetic field weak compared with Earth's, yet unmistakably real. That matters because magnetic fields on rocky planets usually point toward active behavior in the interior, especially the motion of electrically conducting liquid metal. The easy assumption would be that a world this small and battered has long since frozen into complete geologic passivity. Mercury resists that conclusion. Somehow, its interior remains complicated enough to keep part of the system alive. Not lively in the human sense, not dramatic from orbit every day, but not finished either. This is one of the most important reframes in the planet's story. Mercury looks like a remnant, and it is one. Yet remnants are not always dead. Some keep working beneath the surface long after their exteriors begin to resemble ruins. That paradox gives Mercury much of its scientific power. The largest structure on the planet is invisible, yet it controls what the visible world becomes. Even the crust's thinness gains new meaning in that light. A relatively slender rocky shell above such a dominant core means the surface is closer in a structural sense to the planet's deepest governing feature than the surfaces of many larger worlds are to theirs. Mercury is not just scarred on top while something abstract happens below. The distance between wound and cause is reduced. The planet feels almost peeled back toward its own center. That is why the core changes the emotional logic of Mercury as much as the physical one. Without it, Mercury is a small hot planet. With it, Mercury becomes a world defined by buried excess. Too much metal, too little outer rock, too much contraction, too much consequence, flowing from one hidden imbalance. And once that frame is in place, the next layer of the story follows naturally. A planet built this way does not merely cool quietly. It has to register that cooling on its face. Mercury's surface is not just old because little erases it. It is old in a way that remembers both attack from above and tightening from below. The next step is to read those scars properly, because on Mercury, damage is not a side effect. It is the language the planet uses to tell its history. Mercury is not only a world with ancient scars. It is a world that has been slowly pulling itself inward for billions of years. That is a different kind of violence. People tend to imagine planetary drama as something sudden, an impact, an eruption, a collision, a catastrophic event that leaves behind an obvious wound. Mercury has those stories too. But one of the deepest forces shaping the planet is quieter, slower, and in some ways more disturbing. The damage does not arrive from outside in a single blow. It accumulates from within, as the planet cools, contracts, and forces its outer shell to adjust to a body that is becoming smaller than it used to be. The obvious explanation for Mercury's broken surface is bombardment. The deeper explanation is that the planet has also been collapsing into itself, not all at once, but over spans so vast that human intuition can barely hold them together. This is what makes Mercury feel so severe. It is not just a battered archive of old impacts. It is a world whose geology becomes evidence of long-term internal retreat. Once that frame comes into view, The cliffs, ridges, and fault systems covering the surface stop looking like local curiosities and start looking like planetary consequences. A shrinking world cannot hide the fact of its shrinkage. Rock does not politely disappear. Crust does not dissolve away because the interior beneath it has lost volume. Something has to give. On Mercury, what gives is the surface itself. As the great iron-rich core cools through deep time, it contracts. The surrounding layers respond. The crust is compressed. Vast thrust faults form, and sections of the surface are pushed up and over adjacent terrain. The resulting features, known as lobate scarps, cut across the planet like the wrinkles of a sphere that has become too large for the body beneath it. That image matters because it captures the real logic of the process. Mercury's skin is adjusting to a planet that no longer fully fills itself. It is a geological expression of internal loss. These scarps are not small cracks that require scientific generosity to notice. Some extend for hundreds of miles and rise dramatically above surrounding plains. They cross craters, plains, and older terrain, which means they are younger than the landscapes they interrupt. That detail changes the story. If these features had formed only in the earliest chaotic period of the solar system, Mercury could be treated as a world whose major internal drama ended long ago. But the evidence points to contraction continuing well after the planet's first age of violence. In other words, Mercury is not merely preserving a distant past. It has been acting out the consequences of that past across immense later spans. The planet's history is not a single burst followed by stillness. It is a slow tightening, and that tightening has scale. Scientists estimate that Mercury has shrunk radially by more than 4 miles over its history. For a planet only about 3,000 miles across, that is not trivial settling. That is global change. To say Mercury has contracted is to say the entire world has become physically smaller, and that the surface terrain visible today includes the record of that descent. The story on the surface is a field of cliffs and scarps. The story underneath is a planet adjusting to its own diminishing interior. What makes this even more striking is the contrast with Earth. Earth changes constantly, but much of that change is self-erasing. Plate tectonics recycles crust. Wind and water wear down relief. Volcanoes bury older terrain. Oceans hide immense parts of the surface. On Mercury, almost none of that protective forgetting exists. There is no active weather system to sand down the evidence over eons, no global plate network to consume old crust and overwrite the record. Mercury remembers with unusual brutality. Once a feature forms, it has a good chance of staying visible. That is why contraction on Mercury becomes so legible. The planet does not just suffer change, it keeps the receipt. This is one reason Mercury matters so much scientifically despite its size. It preserves a style of planetary history that larger, more active worlds often obscure. It lets researchers study not only what early rocky planets endure, but how internal cooling can become a world-scale structural force. Mercury shows that geologic old age is not the same thing as geological irrelevance. A planet can be ancient, quiet-looking, and still reveal one of the clearest records of long-term planetary contraction anywhere in the solar system. And the implications go beyond topography. Shrinkage tells us something about the pace of Mercury's thermal evolution, the thickness and strength of its lithosphere, the behavior of its interior, and the relationship between buried metal and surface structure. A cliff on Mercury is never just a cliff. It is an exposed line in a much longer argument between interior heat, planetary mechanics, and time. The harder truth is that Mercury's stillness is deceptive. It looks inert because it lacks the obvious movement of Earth. But a planet does not need oceans, forests, clouds, or active mountain belts to be dramatic. Sometimes drama is written in restraint. Sometimes it appears in a crust that has been under compression for ages beyond comprehension. Mercury becomes almost tragic in this light. It begins as a world that may already have lost too much, then spends the next billions of years continuing to diminish, not by crumbling outward, but by drawing inward. The planet does not explode. It tightens. It does not heal. It preserves. And that changes how every visible feature should be read. A crater is not just an impact mark. A plain is not just an old volcanic surface. A scarp is not just a ridge. Each belongs to a larger story in which Mercury is both archive and process survivor and evidence object and consequence. That is the deeper revelation. The planet closest to the Sun is not only being attacked from outside by radiation, solar wind and impacts. It is also carrying the long after effect of its own internal cooling, a slow collapse recorded across the entire globe. Once that becomes clear, Mercury's surface stops feeling merely ancient and starts feeling brutally honest. It shows what happens when a world has almost no way to hide either external violence or internal decline. And that opens the next layer of the descent, because if Mercury is this honest, then its craters and basins are no longer just scenery. They are memory fields preserved with a clarity that few other planets can match. Mercury's craters are not just marks of impact. They are the visible proof that the planet has been left almost nowhere to hide. On many worlds, damage is temporary. Wind softens it. Water buries it. Ice reshapes it. Tectonics breaks and recycles it. Volcanoes erase it beneath newer rock. Time given enough tools becomes merciful. Mercury has almost none of those tools. That is why its surface feels less like terrain and more like testimony. The obvious explanation is that the inner planet gets struck and keeps the scars. True. But that answer is still too shallow, because what Mercury preserves is not just a random collection of holes. It preserves a planetary history of exposure, with unusual clarity, a record of bombardment, flooding, uplift, contraction, and survival written into a face that very little ever gets to revise. This is why Mercury begins to look so severe when seen up close. It is not merely cratered. It is memory made geological. The solar system's earliest age is often imagined as a time of formation, which sounds constructive until its actual meaning becomes visible. Young planets do not emerge gently into finished order. They are assembled inside a violent environment, filled with colliding bodies, drifting debris, unstable orbits, and repeated impacts large enough to remake worlds. Mercury passes through that era closer to the Sun than any other planet in a region where high speeds make collisions especially brutal. The result is not theoretical. It is all over the surface. Craters overlap craters. Giant basins interrupt older terrain. Ejector blankets spread across ancient ground. Mercury does not simply hint that it endured the solar system's violent youth. It presents the evidence almost without mediation, and among those pieces of evidence, few are more important than the Caloris Basin, one of the largest impact structures in the solar system. This immense scar, roughly 960 miles across, is not just a crater in the ordinary sense. It is the remnant of an impact so colossal that it reorganizes the surrounding landscape and leaves effects visible far beyond the basin itself. The blast excavates and shocks the crust, while the energy released disturbs terrain on the opposite side of the planet. This matters because it shifts Mercury's crater record from quantity to consequence. The planet is not only peppered by impacts, it is shaped by some impacts on a planetary scale. A blow large enough to help define global geology is no longer a local event. It becomes part of the world's identity. But even Caloris does not tell the whole story. Mercury's surface also includes smoother plains regions that suggest volcanic flooding in the distant past, where molten material wells up and spreads across older terrain. That complicates the easy picture of a world that is only struck and never answers back. Mercury is not passive stone receiving punishment from space. At least in its earlier history, internal activity also plays a role resurfacing some regions and modifying the record left by bombardment. This is why the planet has to be read carefully. The obvious explanation is impact alone. The deeper explanation is a dialogue between attack from above and response from below. Even so, the dialogue never becomes balanced. On Earth, resurfacing processes eventually dominate so completely that the ancient bombardment record is mostly destroyed. On Mercury, resurfacing happens, but not enough to grant the planet amnesia. Damage remains legible. That is the real revelation. Mercury has enough geology to complicate its history, but not enough to erase it. The result is one of the clearest preserved archives of early planetary violence anywhere among the major planets. This clarity changes how craters themselves should be understood. A crater on Mercury is not merely a hole where something struck. It is a timestamp, a structural disturbance, a clue to crustal strength, a measure of impact conditions, and part of a broader pattern that reveals how long the surface has been exposed. Dense cratering means age. Cross-cutting relationships mean sequence. Superposed faults and later volcanic plains mean the record can be ordered, not just admired. Mercury's face is crowded because time has not been kind, but it has been legible. And that legibility is one of the planet's great scientific gifts. It allows researchers to reconstruct not only what hit Mercury, but how the planet evolves under relentless exposure when there is so little to soften or bury the evidence. There is something almost ruthless in that clarity. A world without mercy from its environment becomes a better witness. That is why Mercury's battered surface feels more than ancient. It feels accusatory. It reminds the viewer that the solar system is not born as a serene arrangement of planets in stable paths beneath a clean sun. It is built through collision loss, heat, and endurance. Mercury simply retains the record with fewer disguises than most. And because impacts remain visible for so long, they begin to merge conceptually with the planet's other forms of damage. External violence and internal contraction start to read as one integrated surface language. A basin can be cut by scarps. A crater floor can be modified by later processes. Old wounds can become platforms for newer deformation. On Mercury, history does not replace history. It stacks. That stacking is crucial because it turns the surface into a layered descent through planetary time. What first appears as monotony turns out to be depth. One scar is not the same as another. One plain is not the same age as the basin beside it. One ridge may speak for cooling, long after the crater it crosses has already existed for ages. This is why Mercury rewards sustained attention more than casual viewing. At first, it seems repetitive. Then it becomes one of the most information-dense landscapes in the solar system. But this density of memory raises a harsher question. Why does Mercury preserve so much so well? The answer is not only age, it is deprivation. The planet lacks the atmospheric shielding weather systems and active crustal recycling that would otherwise blur the record. In other words, Mercury remembers because it is denied the ordinary planetary mechanisms of forgetting. That is the cost behind its clarity. The surface is honest because the world is exposed. And once that becomes the frame, the next step is unavoidable because the cratered severity of Mercury is no longer just about what struck it long ago. It is about the ongoing condition that leaves the planet so undefended now, a world with almost no true atmosphere, almost no cover, and almost no barrier between the sun and the ground below. Mercury is not empty above the ground, but it is unprotected in every way that matters. That distinction is crucial because the language of atmosphere can easily hide the truth. Scientists can accurately say, Mercury has an exosphere, a tenuous envelope of atoms including oxygen, sodium, hydrogen, helium, and potassium. But if that sounds like a thin version of Earth's air, the picture has already gone wrong. Mercury does not possess a true atmosphere in the sense most planets do, not a substantial layer that builds pressure, circulates heat, generates weather shields the surface, or gives the world any meaningful softness. The obvious explanation is that Mercury is too small and too hot to hold much gas. That is part of the answer. The deeper explanation is harsher. Mercury exists in a place where almost every condition works against protection. Its gravity is weak compared with Earth's. Its closeness to the Sun exposes it to intense radiation and a relentless flow of charged particles. Its lack of volatiles leaves it with little material to build a thick atmospheric system in the first place. The result is not merely a planet with thin air. It is a world with almost no defensive layer between the Sun and the rock. That changes everything. On Earth, atmosphere is so constant that it disappears from ordinary awareness. It is not only something breathed, it is a planetary technology. It filters radiation, slows incoming objects, redistributes energy supports, clouds, drives wind, and interacts with oceans and land in a vast system of moderation. Even when weather becomes destructive, the atmosphere remains part of what makes the surface livable. On Mercury, that machinery is almost absent. There is no real cushion, no breathing layer, no climate in the familiar sense, no shield that can turn exposure into habitable experience. The planet faces space almost directly, and the consequences are written into both its surface and its rhythms. This is why Mercury's exosphere should not be imagined as a failed atmosphere waiting to thicken. It is more like a temporary ghost, constantly made and unmade by external violence. Solar wind strikes the ground. Micrometeoroids hit the surface. Atoms are knocked loose from the rocks and briefly hover or leap above the planet before escaping, falling back, or being stripped away again. In other words, what exists above Mercury is not a stable atmospheric body, but an ongoing expression of loss. The exosphere is created partly by erosion. It is a cloud of material being pried off the planet. That fact changes the emotional logic of the world. Even its nearest equivalent to air is not a sign of comfort. It is evidence of exposure. Mercury does not wear a protective shell. It sheds particles under assault. This is where the planet's lack of mercy becomes clearest. Without a substantial atmosphere, sunlight does not meet layers of cloud vapor and moving gas before reaching the ground. It reaches stone. Without a buffering blanket, heat gained in sunlight is not efficiently shared across the world or stored in the way it is on planets with thicker air. It builds where the sun shines and vanishes where darkness takes over. Without pressure and chemistry operating at atmospheric scale, weather never becomes a geological partner. There is no rain to carve valleys, no wind system to sweep dunes across continents, no storm front to redistribute the burden of energy. Mercury is left with a more primitive arrangement: light rock darkness exposure. That simplicity is not elegant. It is brutal. Even impact has a different meaning under such conditions. Small incoming objects that might burn up in thicker atmospheres elsewhere can reach Mercury's surface more directly. Radiation arrives with fewer obstacles. Surface materials experience space weathering under a regime of direct contact. The ground is not hidden beneath a protective medium that absorbs part of the punishment. It receives the punishment itself. This is why the absence of atmosphere on Mercury should be understood not as a missing accessory, but as a governing planetary condition. A world without a substantial atmosphere is not merely quieter than Earth. It is fundamentally rearranged. Time behaves differently there. Heat behaves differently there. Damage behaves differently there. Memory behaves differently there. The planet's entire surface experience is redefined by the fact that almost nothing intervenes. And yet Mercury's weakness is not absolute. The planet still possesses a magnetic field, faint but global, which interacts with the solar wind in ways that complicate the story. At first glance, this seems like a partial rescue, a sign that Mercury retains some shield against the Sun. But again, the easy explanation fails. Mercury's magnetic protection is limited, asymmetric, and inadequate to create anything like Earth's protected near-surface environment. Instead, it becomes one more paradoxical feature of the planet, enough internal dynamism to generate a magnetic field, but not enough external defense to make the world safe. In some ways, that is more revealing than total helplessness would be. Mercury is not a dead stone lying passively beneath a star. It is a damaged world still trying to resist conditions that remain fundamentally hostile. That struggle gives the planet a severe dignity. It has almost no atmosphere, but it still carries traces of interior action. It cannot build weather, but it can still interact electrically and magnetically with the Sun. It cannot protect its surface well, but it can register everything that protection would otherwise have softened or erased. This is why Mercury becomes one of the clearest laboratories for understanding what a rocky planet looks like when environmental mediation is stripped away. It is not simply hot because it is near the Sun. It is raw because almost nothing stands between the Sun and the ground. That distinction is the whole point. Proximity provides the intensity. Lack of atmosphere provides the exposure. Together, they produce a world where the ordinary planetary functions of shielding, balancing, and forgetting are reduced nearly to zero. And once that is understood, the next consequence emerges with almost brutal inevitability. A planet so exposed does not merely become cratered and airless. It becomes a world of extremes where the day side and night side drift so far apart in temperature that Mercury stops looking like a coherent environment at all and begins to resemble a single planet split into incompatible states of existence. Mercury is close to the Sun, yet it is also one of the coldest places a human mind can easily imagine. That sounds impossible until the planet is understood properly. In ordinary intuition, closeness to a star should mean persistent heat. A world near the Sun ought to feel uniformly scorched, overwhelmed, saturated with warmth. But Mercury refuses that simple picture because heat is not the same thing as protection, and exposure is not the same thing as stability. The obvious explanation is that Mercury is hot because it stands nearest the Sun. The deeper truth is that Mercury is unstable in thermal terms because it has almost no way to hold what it receives. Sunlight strikes the surface with ferocious intensity, but the world lacks the atmospheric machinery required to distribute, regulate, and retain that energy in any gentle or coherent way. The result is not continuous oppression, it is violent contrast. Mercury does not simply burn, it swings. It lurches between extremes so severe that the day side and night side seem less like opposite faces of one planet than like incompatible environments forced to share the same body. This is why Mercury begins to feel less like a place and more like a planetary experiment in what happens when energy arrives without mediation. During the long Mercurian day, surface temperatures can climb to around 800 degrees Fahrenheit. That number alone is enough to place the planet among the most punishing surfaces in the solar system. But the real shock comes later, when darkness takes over, and it takes over for an immense stretch. Temperatures can plunge toward 290 degrees below 0 Fahrenheit. That descent is not a minor nightly cooling. It is a collapse into a different thermal reality. Mercury is not hot in the way a kitchen oven is hot, where insulation traps energy, and the heat remains part of a controlled system. It is hot in the way exposed metal under a blasting light is hot. Scorching under direct input, and then surrendering that energy rapidly when the source is gone. Without a thick atmosphere, there is no global blanket to slow the escape. Without oceans, there is no fluid reservoir to absorb and release heat gradually. Without weather, there is no circulation to even out the burden between lit and dark hemispheres. Mercury receives and loses. It does not balance. That distinction gives the planet its particular cruelty. Time makes the cruelty worse. Mercury rotates slowly, and its orbital relationship with the Sun is strange enough to turn ordinary notions of sunrise and sunset into something far more severe. The planet is locked in a 3-to-2 spin-orbit resonance, rotating 3 times for every 2 trips around the Sun. Because of that, a solar day on Mercury lasts 176 Earth days, even though the planet completes an orbit in just 88 Earth days. This means the Sun's movement across the sky is not merely slow. It is prolonged to a degree that transforms thermal experience into endurance. When sunlight settles over a region, it does not pass quickly. It lingers. It keeps pressing. It keeps loading energy into the ground. Then, when darkness comes, the cold has time to deepen with equal patience. Mercury is not whipped back and forth between day and night in short shocks. It is held inside each condition long enough for the condition to become nearly absolute. That is why the planet's extremes are not just about intensity. They are about duration. A place can survive brief violence. Mercury has to endure prolonged exposure. Even the clock is against it. And yet, the planet contains one more contradiction, because the same world that becomes infernal under direct sunlight can preserve water ice in permanently shadowed craters near its poles. At first, this sounds like the kind of fact included only to surprise. In truth, it deepens the whole logic of Mercury. The obvious explanation is that a planet near the Sun should be too hot for ice anywhere. The real explanation is that temperature on Mercury is radically local when sunlight is absent. In deep polar craters whose floors never receive direct solar illumination, heat never truly arrives. Those regions remain cold traps, protected not by atmosphere but by geometry. Sunlight governs Mercury so thoroughly that where light does not reach, conditions can become cold enough for ice to survive even on the innermost planet. This is one of the most revealing facts in the solar system. Because it shows that Mercury is not simply a hot world. It is a world of brutal thermal inequality. Some places are punished by prolonged radiation, some are preserved by permanent shadow. The same planet contains both extremes because almost nothing exists to smooth the differences out. Mercury does not average its conditions, it segregates them. That has consequences not only for chemistry and surface processes, but for how the planet should be imagined at all. Earth invites the idea of a global environment. Mercury resists it. It is not one stable setting spread across a sphere. It is a collection of sharply divided regimes, each defined by exposure, angle, shadow time, and the absence of moderation. This is why the planet closest to the Sun becomes, in a deeper sense, one of the most fragmented worlds in the solar system. Not fragmented into pieces, but fragmented into physical realities that barely reconcile with one another. Fire and ice do not alternate there in the poetic sense. They occupy the same world because nothing blends them, and that returns the story to its real center. Mercury's thermal violence is not merely a fact about sunlight. It is the clearest expression of a larger planetary condition, a world denied the systems that turn raw energy into livable order. The Sun provides the force. Mercury's lack of atmospheric and environmental mediation turns that force into extremity. Once that becomes visible, the next layer follows naturally, because a planet that lives under such direct solar rule is not only heated and frozen by the Sun. It is also governed by the Sun's gravity radiation and particles so completely that even Mercury's speed timing and surface chemistry begin to look less like independent planetary traits and more like signs of a deeper domination. Mercury does not simply orbit the Sun. It lives under a kind of permanent domination. That is the frame the planet keeps forcing into view. On a classroom diagram, all the planets seem to belong to one orderly family, arranged in neat paths around a central star. In that picture, Mercury is just the first member of the line closer, in faster moving, more strongly lit. But the closer one looks, the less adequate that calm geometry becomes. Mercury is not merely near the Sun in the way Mars is farther from it, or Earth is set between extremes. Mercury exists inside a harsher regime, one where solar gravity radiation and streams of charged particles shape the planet so continuously that its own identity begins to look inseparable from the power pressing on it. The obvious explanation is that the Sun is stronger there. The deeper truth is that Mercury lives so close to the source that it is never allowed to forget what rules it. Distance in the solar system is not just spacing. It is a measure of how much mercy a planet receives. Earth gets enough distance for a thick atmosphere, liquid water, and a more moderated exchange with sunlight and solar wind. Mercury receives something else. It receives exposure without relief. Solar gravity holds the first piece of that story. Every planet is bound to the Sun, but Mercury is bound more tightly than any other. Its average orbital distance of roughly 36 million miles places it in a region where the Sun's pull becomes not merely the organizing force of the planetary system, but an overwhelming daily fact. The planet races along its path at speeds greater than 100,000 miles per hour because the Sun does not permit slowness there. Mercury is forced into haste by the depth of the gravitational well it inhabits. And that haste has consequences. A more eccentric orbit means the distance between Mercury and the Sun varies over the course of a year, which means the intensity of solar influence varies too. The Sun does not command Mercury in one flat, constant way. It modulates pressure, speed, and heating as the planet swings closer and farther along its ellipse. Even the shape of Mercury's year becomes a sign of subordination. But gravity is only the beginning. The Sun also sends out a continual flow of charged particles known as the solar wind, and Mercury is exposed to that assault more directly than any other planet with a solid surface. On Earth, a thick atmosphere and a strong magnetosphere help absorb, deflect, and soften much of that pressure. Mercury has neither luxury in anything like the same degree. It does possess a global magnetic field, one of the most surprising facts about the planet. But that field is weak and strange offset in a way that creates uneven protection. Instead of creating a secure barrier, it produces a shifting interaction with solar particles. In effect, Mercury is not fully shielded from the Sun's electric violence. It negotiates with it badly. Charged particles can still reach the surface more easily than intuition would prefer, sputtering atoms loose from rocks and feeding the thin exosphere that drifts above the ground. This matters because it reveals that Mercury's near airlessness is not merely a static condition. It is maintained by an active relationship with the Sun. The planet's exosphere is constantly replenished and disturbed by solar influence. The Sun is not just warming Mercury, it is actively stripping material from it. That is a harsher kind of proximity. It turns the star from a source of light into an agent of erosion. Radiation completes the pattern. Sunlight on Mercury is not just bright. Ultraviolet radiation and energetic particles alter surface materials directly in a long process of space, weathering, darkening, and modifying the planet's uppermost layers over immense spans of time. Here again, Mercury differs not only in degree, but in kind. A world with clouds, weather, water, or active crust can partially reset what radiation and micrometeoroids do. Mercury cannot. It keeps receiving the signal. It keeps accumulating the damage. The same Sun that defines the inner solar system as a source of life for Earth becomes, at Mercury's distance, a relentless editor of the planetary surface. Even Mercury's magnetic field, which at first sounds like a token of resistance, becomes another sign of the imbalance. Because the field is weak and displaced northward, the planet's interaction with solar wind is asymmetric. Some regions are more vulnerable than others. The magnetosphere can be compressed dramatically by solar activity. In extreme conditions, the boundary between planetary defense and direct solar contact becomes frighteningly thin. Mercury is not just orbiting inside sunlight. It is operating at the edge of what a rocky planet can endure without more substantial protective systems. This is why Mercury begins to feel so revealing. It shows what happens when a terrestrial world is placed close enough to a star that the star ceases to be background and becomes environment. For Earth, the Sun is central but moderated by distance and planetary systems. For Mercury, moderation largely collapses. Gravity drives its extraordinary speed. Radiation hammers its surface. Solar wind helps maintain its ghostly exosphere by knocking atoms free. The magnetosphere offers only partial and uneven resistance. Heat arrives intensely and leaves brutally. In every direction, the same lesson appears. Mercury is not merely illuminated by the Sun. It is governed by it. And that governance changes how motion itself must be understood. The planet's great speed is not a flourish. It is a consequence of living deep in the Sun's grasp. Its strange day-night rhythm is not an odd clockwork curiosity. It is what happens when rapid orbital motion and slow rotation are forced into a difficult compromise. Even Mercury's fame as the swift messenger begins to look incomplete. Speed is the visible result. Domination is the cause. Once that becomes clear, the next layer of the story opens on its own, because Mercury's motion is no longer just a fact to memorize. It becomes one of the strangest expressions of solar rule in the solar system, where orbit rotation and even the experience of time itself are bent into a pattern that only makes sense this close to the Sun. Mercury is the fastest planet in the solar system, yet one of the strangest things about it is how slowly the experience of a day unfolds. That contradiction goes to the heart of the planet. Speed taken by itself sounds simple. The innermost world lives closest to the Sun, so it must move fastest. That much is true. Mercury tears around the Sun at an average speed of more than 100,000 miles per hour and completes an orbit in just 88 Earth days. The ancient observers who named it after a swift divine messenger were not wrong. They could see the planet never wandered far from the Sun and slipped quickly through the twilight sky, elusive and hard to catch. But the real story is not velocity alone. The real story is that Mercury's motion creates one of the most alien relationships between orbit rotation, sunlight, and time found anywhere among the major planets. The obvious explanation is that Mercury races around the Sun. The deeper truth is that this speed distorts the basic meaning of day and year until the planet stops feeling like a normal world with a normal clock and starts feeling like a place trapped inside a celestial compromise. On Earth, time at the surface feels stable because the planet spins once roughly every 24 hours while circling the Sun once each year. The motions differ so greatly that daily life and yearly change remain easy to separate. Sunrise and sunset belong to rotation. Seasons belong to orbit. The mechanisms are distinct enough that human experience turns them into background. Mercury does not allow that comfort. It rotates very slowly, taking about 59 Earth days to turn once on its axis, while it circles the Sun in just 88. This by itself would already make the planet strange. But Mercury does not simply spin slowly and orbit quickly as independent facts. The two motions are locked into a 3-to-2 spin-orbit resonance. For every 2 trips around the Sun, Mercury rotates exactly 3 times. That means the planet's year and its spin are not separate rhythms accidentally coexisting. They are dynamically entangled. The result is one of the most counterintuitive clocks in the solar system. A solar day on Mercury, the interval from one noon to the next at the same location, lasts 176 Earth days. In other words, one full cycle of sunlight across the sky takes twice as long as the planet's year. This is where the easy image of a fast little planet starts to collapse. Mercury can race through space while dragging sunlight across its surface with enormous slowness. The planet is swift in orbit and sluggish in lived time. That combination matters because it turns exposure into endurance. Long days mean prolonged heating. Long nights mean prolonged cooling. The thermal brutality described earlier is inseparable from this clockwork. Mercury's motion is not just a fact of celestial mechanics. It is one of the engines of the planet's environmental extremity. And the strangeness goes further. Because Mercury's orbit is noticeably elliptical, its orbital speed changes significantly over the course of a year, increasing near perihelion, its closest approach to the Sun, and decreasing farther out. Near perihelion, the planet sweeps so quickly along its orbit that from certain longitudes on the surface, the Sun's apparent motion across the sky can stall, reverse, and then resume. Imagine a sunrise that does not simply rise. Imagine the Sun climbing, hesitating, moving backward, and then advancing again. On Mercury, that can happen. This is not poetic exaggeration. It is the visible consequence of a world whose orbital motion can temporarily outpace the normal progression of its own rotation as seen from the surface. At that point, Mercury ceases to feel like a place governed by familiar astronomy at all. It feels like a planet where the sky itself cannot decide on a direction. And yet, this bizarre behavior is not random. It is the lawful product of gravity resonance and eccentric motion. That is what makes it so revealing. Mercury demonstrates that the closer a world moves to the Sun, the less ordinary even basic cycles become. What looks from afar like simple speed becomes on the surface a deep rearrangement of time. This is why Mercury cannot be understood properly as just the first planet in line. Its motion is not merely more intense than Earth's. It belongs to a different regime of lived experience. The distinction between day and year begins to blur. The Sun behaves strangely overhead. Heat and darkness linger with punishing patience. The planet's famous swiftness, which once seemed like its defining trait, turns out to be only one part of a larger distortion. Mercury is not simply fast. It is temporally misaligned in a way no human civilization has ever had to inhabit. Even the concept of noon acquires a different weight on a world where solar motion is so extended and unstable in appearance. There is also a deeper scientific consequence to Mercury's orbit, one that reaches beyond the surface and into the history of physics itself. For centuries, Mercury's path around the Sun revealed a slight anomaly in the precession of its orbit, a tiny advance in the point of closest approach that classical Newtonian mechanics could not fully explain. This discrepancy was small, but it mattered because small unresolved errors become large when they survive every simpler fix. Mercury, the planet most dominated by the Sun, became one of the places where the limits of older gravitational understanding were exposed most clearly. The unexplained portion of Mercury's perihelion precession was later accounted for by Einstein's general theory of relativity, which described gravity not as a simple force pulling through empty space, but as the curvature of space-time itself. That is an extraordinary escalation. A small, battered world near the Sun turns out to help reveal that the geometry of the universe is stranger than classical physics had imagined. The story on the surface is a fast orbit. The story underneath is that Mercury lives so deep in the Sun's gravitational field that even the old rules of celestial certainty begin to bend. This gives the planet a special kind of importance. Mercury is not only a victim of solar domination, it is also one of the clearest witnesses to what that domination means at extreme proximity. Its year is short, but its solar day is immense. Its sunrise can reverse. Its orbit helped expose the incompleteness of older physics. Motion on Mercury is never just motion. It is evidence that ordinary intuitions fail near the source of power. And yet, for all this external strangeness, one harder question remains. A world this small, this battered, this thermally brutal, and this dominated by the Sun ought to be simpler inside than it actually is. By every easy expectation, Mercury should be little more than a wounded clockwork ruin. But it is not. Beneath the scarred crust and the distorted sky, something still lingers, because the next revelation is even less intuitive than Mercury's warped sense of time. This seemingly exhausted planet still carries a magnetic field, as though some buried part of it refuses to go entirely silent. Mercury should have gone quiet long ago. That is what size, age, and appearance seem to promise. Small rocky planets lose heat faster than larger ones. Their interiors are expected to settle their geological activity, to fade their deep engines, to weaken, until the world becomes little more than a cold shell carrying old wounds. Mercury looks exactly like the kind of planet that should fit that fate. It is small. It is heavily cratered. It lacks a thick atmosphere. It sits under punishing solar conditions that make it seem less like a living world than a hardened remainder. By every easy intuition, Mercury ought to be internally finished, but it is not. That is where the story turns again. The obvious explanation is that Mercury is a dead world still carrying the marks of an active past. The deeper truth is more unsettling. Some buried part of the planet remains capable of motion enough to generate a global magnetic field. That single fact changes the entire emotional logic of Mercury. A magnetic field is not decoration, it is evidence. On rocky planets, it usually points to the movement of electrically conducting material inside most often liquid metal in the core. In other words, Mercury's damaged exterior conceals a lingering internal dynamism that the surface alone does not prepare you for. This matters because it breaks the easy story of decline. Mercury is not simply a remnant cooling towards silence. It is a remnant still carrying a low but persistent internal signal. That signal is weak compared with Earth's field, but weakness is not the point. The point is existence. Mercury should not be this easy to dismiss if some part of its interior is still active enough to matter. That revelation begins with comparison. Earth's magnetic field is familiar because it surrounds human life so completely that most people never think about it at all. It arises from the convecting motion of molten iron in the outer core, shaped by planetary rotation into a global magnetosphere that helps shield the atmosphere and surface from solar wind. Mercury's field is far smaller and less protective, yet it is still recognizably planetary. This is extraordinary because Mercury is so much smaller than Earth and should in principle have lost internal heat faster. That raises the real question. How does a world this old and this small still maintain the kind of deep activity required to produce a magnetic field at all? The answer is not fully settled, which makes the planet even more valuable. Mercury is not just giving scientists conclusions, it is forcing them into deeper physics. One leading explanation is that at least part of Mercury's oversized core remains molten, and that the planet's unusual composition helps preserve conditions under which a dynamo can continue operating. Sulfur or other light elements mixed into the core may lower the melting point of the metal, allowing liquid layers to survive longer than a simpler model would predict. In that view, Mercury's massive core does not merely make the planet dense. It prolongs a hidden interior complexity that smaller rocky worlds are not expected to retain so clearly. The story on the surface is a battered ancient crust. The story underneath is a metallic interior whose thermal evolution may be delayed, stratified, or chemically peculiar enough to remain active far longer than appearance suggests. That is the deeper pattern Mercury keeps revealing. What looks simplified from outside becomes more complicated the closer it is examined. Even the magnetic field itself is strange. It is not centered neatly within the planet the way an idealized textbook diagram might lead you to expect. It is offset northward, meaning the geometry of Mercury's magnetism is asymmetric. That asymmetry matters because it produces an uneven relationship with the solar wind, altering how charged particles interact with the planet at different latitudes. The result is not a comforting bubble of protection. It is a compromised field, partial, displaced, and revealing. Mercury is again caught in a familiar pattern: enough internal power to resist total passivity, but not enough outward defense to create safety. Its magnetic field does not rescue the planet from the sun. It exposes the complexity of the struggle. That struggle becomes even more dramatic when solar activity intensifies. Mercury's magnetosphere can be compressed severely, its boundaries pushed inward under strong solar pressure. In moments like that, the distinction between shielding and exposure narrows alarmingly. Charged particles are funneled toward the surface more readily in some regions, helping release atoms from the ground and feeding the exosphere. The field is real, but so is its inadequacy. That is one reason Mercury feels so severe as an object of study. Almost every protective mechanism it possesses exists in reduced form. The planet is never entirely without structure, without resistance, without internal life, but neither is it ever given enough to become stable in the comfortable sense. Everything is partial, everything is strained, everything is revealing. There is also a larger scientific implication here. Mercury's magnetic field makes the planet an important test case for how rocky worlds evolve, cool, and remain active under extreme conditions. It pushes against overly simple models in which size alone determines destiny. Instead, it suggests that composition, core fraction chemistry, rotational history, and interactions with the star all matter in shaping planetary survival. That broadens Mercury's importance well beyond the inner solar system. Worlds around other stars may also exist in conditions of intense exposure, thin atmospheres, metal-rich interiors, and prolonged magnetic struggle. Mercury becomes not just a local oddity, but a nearby example of how a planet can remain more internally complicated than its ruined exterior implies. This is one of the deepest reframes in the whole story. Mercury begins as the smallest and apparently simplest of the terrestrial planets. It becomes step by step a place where simplicity fails at every meaningful level. The crust is scarred, but the core still matters. The atmosphere is almost absent, but a magnetosphere still flickers into existence. The planet seems dead, yet some part of it still moves. That is why Mercury's field carries such narrative weight. It is not important merely because it exists. It is important because it proves the planet is not fully exhausted. Beneath the cliffs, basins, and ancient plains, the buried metal heart has not gone entirely still. And once that is understood, the meaning of Mercury changes again. It is no longer enough to describe the world as damaged. The harder question is, what kind of planet can survive this much punishment, this much loss, this much exposure, and still retain a hidden capacity to act from within? That question widens the frame. Mercury stops being just the innermost planet and becomes something larger, a planetary limit case where formation trauma cooling magnetism and solar domination all converge. The next step is to see the surface not as a collection of separate features, but as a single integrated record of that convergence, because once Mercury's buried life is admitted, every cliff, basin, plain, and fracture has to be read again as part of one world-scale pattern of stress survival and meaning. Mercury's surface is not a collection of features. It is a single argument spread across an entire planet. That is the reframe the story now demands. Up to this point, Mercury can still be misunderstood as a world composed of separate oddities, an oversized core, a shrinking body, immense craters, long cliffs, savage temperature swings a weak magnetic field that should not still exist. Each fact is striking on its own. But the deeper truth is that none of them truly stand alone. The basin's plains, scarps, fractures, and ancient crater fields are not isolated entries in a catalogue. Together, they form one connected record of how Mercury is built, how it is damaged, how it cools, and how it survives. The obvious explanation is that the planet's surface is complicated because many different things happen to planets over billions of years. The real explanation is harsher and more elegant. On Mercury, many of those processes remain visible at once because so little has been allowed to erase them. The world does not merely contain history, it layers history. It preserves the overlap between causes. It allows impact volcanism contraction and solar exposures to remain in direct conversation on the same ground. That is why the planet begins to feel less like scenery and more like a planetary document written in multiple hands across the same page. Consider what that means in practical terms. A giant impact creates a basin so large it reorganizes whole regions of the crust. Later, volcanic material floods or partly smooths nearby terrain, filling lower areas and changing the local appearance of age. Then, planetary contraction produces scarps that cut across older structures, proving that the world is still responding internally long after the Great Bombardment has done much of its work. Micrometeoroid impacts continue to pepper the surface. Solar wind and radiation continue to weather exposed material. The result is not chaos, it is sequence. Mercury's landscape becomes readable because different forms of damage and modification cross one another in ways that reveal timing. A cliff that slices across a crater must be younger than the crater. A plain that buries older rough terrain must arrive later than what it covers. A basin surrounded by disturbed terrain and intersected by later scarps belongs to more than one chapter at once. This is why Mercury rewards geological reading so intensely. It is not only ancient, it is structured. The world's face contains chronology in physical form. And once that chronology is recognized, a deeper pattern emerges. Mercury is shaped by pressure from both directions. It is struck from above and compressed from below. That distinction is one of the keys to understanding the whole planet. Impacts tell the story of a world exposed to external violence in the early solar system and afterward. Scarps and contractional tectonics tell the story of a world whose interior cools and shrinks, forcing the crust to accommodate lost volume. Volcanic plains hint at periods when internal heat still finds expression at the surface. Space weathering records the constant touch of the sun and surrounding environment. On another planet, these processes might be spaced apart so thoroughly or erased so efficiently that the integrated story becomes difficult to recover. On Mercury, they remain legible together. That is why the surface matters so much. It reveals that the planet is not defined by one trauma. It is defined by the cumulative interaction of many traumas, some sudden, some slow, some external, some internal, all preserved, because almost nothing is available to soften the record. This gives Mercury a kind of brutal coherence. The world does not look active in the lush terrestrial sense. It does not advertise motion through storms, plate boundaries, oceans, or changing clouds. Yet the more one studies its terrain, the more motion appears everywhere in delayed form. A crater is the frozen memory of impact. A smooth plain is the frozen memory of eruption or flooding. A scarp is the frozen memory of contraction. A darkened surface grain is the frozen memory of solar and meteoritic exposure. Mercury may look still, but its stillness is densely encoded. The planet is not lifeless in a scientific sense. It is post-event and mid-consequence at the same time. Some of the most important things that happen to it are already over. Some are ongoing in slow form. All of them remain visible. That is a rare combination. It turns the entire globe into a map of accumulated stress. There is also a more unsettling implication. On Earth, surface complexity often suggests richness of process and environment. On Mercury, complexity often means repeated forms of injury preserved with unusual honesty. The planet's beauty, where it appears, is austere. Broad plains, towering scarps, giant basins, and heavily cratered expanses do not describe a world of flourishing interaction. They describe a world that has endured without shelter. That is why Mercury's terrain must be read morally with caution, but emotionally with seriousness. The features are not wounds in the human sense, yet they function like wounds in narrative terms. They reveal where the planet has been struck, squeezed, resurfaced, and exposed. They mark where history accumulates faster than forgetting. This is one reason Mercury can feel more severe than larger and more spectacular planets. Jupiter overwhelms with scale. Saturn dazzles with form. Venus terrifies with atmosphere. Mercury does something quieter and in its own way colder. It reveals what a rocky world looks like when the ledger of damage stays open. Once that is understood, the planet's surface stops being a set of landmarks and becomes a total pattern. Caloris is not just a basin, it is one node in a network of consequences. Lobat scarps are not just cliffs, they are the visible syntax of planetary contraction. Cratered highlands are not just ancient terrain, they are preserved exposure. Smooth plains are not just exceptions to roughness. They are signs that even this wounded world once had enough inner heat to answer back. The achievement of Mercury is real. It remains intact. The cost is larger. It remains legible. And that is the reframing Section 12 has to deliver. Mercury is not a random assortment of extremes. It is a coherent world whose entire visible face records the long interaction between structure punishment and survival. Yet that same clarity creates a final paradox. A planet this revealing should have been central to human imagination long ago. Instead, for most of history, Mercury remains obscure, difficult, half-seen, and strangely neglected. The next layer of the story is not on the planet itself, but in our relationship to it, because one of the most exposed worlds in the solar system is also one of the hardest for human beings to truly know. Mercury has always been right there, and that is one reason it remains so hard to know. A planet can be hidden by distance, by darkness, by size, by remoteness beyond the familiar architecture of the inner solar system. Mercury is hidden by something more humiliating. It is hidden by nearness. The world closest to the Sun spends most of human history, not as a central object of wonder, but as a fleeting point in bright twilight, visible only briefly low on the horizon, half lost in glare, and gone before sustained attention can settle on it. The obvious explanation is that Mercury is obscure because it is small. The deeper truth is that it is obscure because the Sun refuses to let it be seen easily. Mercury is one of the major worlds of the solar system, yet for long stretches of history it remains less emotionally present than Mars, less visually commanding than Venus, and less narratively accessible than bodies much farther away. It is not absent because it lacks importance. It is absent because it is difficult, and difficulty has consequences. Ancient observers know Mercury exists. They see it darting through the dawn or evening sky, never wandering far from the Sun, always appearing swift, temporary, and evasive. That is enough to give the planet its name and early reputation, but not enough to reveal its nature. A world that only appears in short windows does not readily become a landscape in the mind. It becomes a recurring clue, a signal without full context. For centuries, Mercury remains trapped inside that condition. Telescopic astronomy improves human sight, but the planet still resists intimacy. It is small in apparent size. It is often seen through thick atmosphere near the horizon, where air distorts images badly. It does not yield the easy visual drama of Jupiter's moons, Saturn's rings, or the changing glow of Venus. Mercury stays difficult to resolve, difficult to map, difficult to turn from point of light into place. This is where scientific neglect begins to acquire structure. The problem is not lack of curiosity. The problem is that some objects reward observation generously while others make every answer expensive. Mercury belongs to the second group. Even for spacecraft, the planet is harder to reach than its distance from Earth might suggest. That sounds backward until orbital mechanics are taken seriously. The obvious explanation is that Mercury is close, so a mission there should be simple compared with journeys to the outer solar system. The real problem is not distance alone. It is speed and gravity. A spacecraft falling inward toward the Sun gains enormous velocity, and arriving at Mercury is not simply a matter of going there. It is a matter of slowing down enough not to rush past. In practical terms, that means missions to Mercury require complicated trajectories, repeated gravity assists, and serious engineering to survive the thermal environment near the Sun. The nearest major planet becomes one of the hardest to visit properly. Again, Mercury reveals the same pattern. Nearness should make it easier. Nearness makes it harder. For a long time, that difficulty shapes human knowledge. Mercury is not a blank world, but an under-resolved one known through fragments, timing windows, and hard-won glimpses. As a result, it is easy to underestimate. When a planet looks small, airless, and ancient, there is a temptation to treat it as relatively straightforward, as though it must be a simpler version of the rocky worlds already better known. Mercury punishes that assumption. Each closer look has a way of enlarging the problem. The core is too large. The density is too high. The surface is more layered. The contraction is global. The magnetic field still exists. The exosphere is not a trivial footnote, but a dynamic sign of solar stripping. Even the orbit plays a role in the history of modern physics. The world that seems easiest to dismiss becomes increasingly difficult to reduce. That is why Mercury's obscurity matters so much. It is not just a historical accident. It is part of the planet's meaning. Standing too close to power can make an object harder to understand, not easier. The Sun lights Mercury, but it also blinds inquiry. Mercury is one of the clearest planetary limit cases in the solar system. A world that shows what happens when a rocky body is formed, altered and forced to endure near the edge of solar tolerance. Yet because it lives in the Sun's glare, it spends much of human history under-imagined. The most exposed planet becomes one of the least seen. Each new phase of observation tends not to tidy Mercury into simplicity, but to fracture older assumptions. Mercury does not shrink intellectually when examined. It expands. Its surface turns into a better archive than expected. Its interior becomes less dead than assumed. Its environment becomes more active than an almost airless world seems entitled to be. The cost of observation is high. The consequence is that Mercury occupies a peculiar place in planetary science, familiar in name, unfamiliar in substance. People know it as the first planet. They rarely know what that firstness means. They know it is fast. They often do not know how strange its day is. They know it is near the Sun. They often do not grasp that nearness as a condition of exposure, deprivation, and endurance. This gap between recognition and understanding is part of Mercury's narrative weight. It is the world most likely to be mistaken for simple by anyone who has not looked carefully. Not all difficulty comes from distance. Not all mystery lies in the outer dark. Some of the hardest truths sit close to the source of light, partly visible, repeatedly overlooked, waiting until tools improve enough to reveal that the familiar object was never familiar at all. Mercury, in that sense, is not only a planet, it is a warning about appearances. Small does not mean simple. Near does not mean known. Visible does not mean understood. And once that becomes clear, the next step in the story becomes necessary because Mercury changes when human beings finally reach it more directly and turn scattered glimpses into something harsher and more complete. A planetary revelation won the hard way. Mercury does not reveal itself willingly. It has to be pried open by effort, trajectory, timing, and machines built to survive a place that punishes proximity. That is what makes the age of exploration so important here. On many worlds, a mission adds detail to what people already broadly understand. On Mercury, the missions do something more radical. They force a reclassification. The obvious explanation is that spacecraft finally take better pictures of a small inner planet and fill in missing facts. The deeper truth is that every successful encounter with Mercury exposes how incomplete the earlier picture really is. The planet does not become clearer in a narrow sense. It becomes larger in meaning. It stops being a dim point of light with a reputation for speed and turns into one of the most revealing case studies in planetary science, a world where formation impact history, internal evolution, magnetic survival and solar domination all meet at once. The first major step comes with Mariner 10 in the 1970s, and even that mission arrives under the sign of limitation. It becomes the first spacecraft to visit Mercury using gravity assist techniques that already hint at how hard this planet is to reach properly. Mariner 10 does not map the whole world. It cannot. But what it does reveal is enough to break the old simplicity. Mercury is not a bland, scorched sphere. It is heavily cratered, ancient-looking, and unexpectedly moon-like in some regions, yet not merely another airless relic. It has giant basins. It has global-scale structures. Most importantly, Mariner 10 discovers that Mercury possesses a magnetic field. That single result is a shock powerful enough to reorganize the entire conversation. A tiny, battered planet this close to the Sun should not still be carrying a sign of interior dynamism so clear. In one stroke, Mercury ceases to be trivial. It becomes anomalous, and anomalies are where science deepens. But Mariner 10 still leaves enormous gaps. Much of the planet remains unseen. Many of the most important questions remain alive. How large is the core exactly? How extensive is the contraction? What is the chemistry of the surface? How active is the interaction with the solar wind? Is the magnetic field ancient residue or evidence of something more persistent? This is where Mercury's pattern returns once again. Every answer does not close the case. It exposes a deeper layer underneath. The world remains only partly visible, and partial visibility can be more provocative than ignorance, because it shows just enough strangeness to make certainty impossible. Then comes Messenger, and the scale of the reframe becomes undeniable. After a long and technically demanding journey involving multiple planetary flybys, the spacecraft enters orbit around Mercury in 2011 and transforms the planet from a difficult target into a sustained object of study. The importance of that change cannot be overstated. Flybys can surprise. Orbit can interrogate. Messenger maps the entire surface. measures the magnetic field in far greater detail, refines understanding of the planet's composition, reveals the extent of global contraction more fully, and confirms that Mercury is not just metal-rich in a broad sense, but chemically more complex and more revealing than earlier models had allowed. The surface is not merely cratered, it includes evidence of ancient volcanism on a significant scale. The tectonic story is not local, it is global. The magnetic field is not centered neatly, but offset. The poles contain water ice in permanently shadowed craters, one of the most startling facts about the innermost planet, because it shows again that Mercury is not a simple hot world, but a world of thermal segregation, so severe that deep shadow can preserve what direct sunlight would destroy. Messenger does not make Mercury less strange. It proves that the strangeness is systemic. This is what exploration does at its best. It turns scattered anomaly into coherent worldhood. Mercury's outsized core, weak but real magnetic field, volatile bearing surface materials, contractional scarps, giant impact basins, and polar ice deposits are not random curiosities. They are parts of one planetary identity. A world long dismissed as small and straightforward becomes a compressed archive of how rocky planets form suffer-cool and endure under extreme conditions. That change in perspective is one of the great achievements of modern planetary science. The achievement is real. The cost is larger. It takes decades, immense engineering effort, and missions designed around the very problem Mercury represents, that it is close in space but hard in physics. Even now, the story is not complete. Bepi Colombo, the joint mission of Europe and Japan, continues. That next chapter built not merely to revisit Mercury, but to deepen the interrogation with complementary orbiters capable of probing its interior magnetic environment, surface composition, and relationship with the Sun, more precisely than before. That continuing effort matters because Mercury has become more than a destination. It has become a test. Can planetary science explain how such a small world ends up with such a dominant metal core? Can it fully reconstruct the thermal history that allows the planet to shrink and yet retain an active dynamo? Can it explain the exact pathways by which solar wind exosphere, magnetosphere, and surface chemistry interact under extreme solar pressure? Mercury no longer sits at the edge of knowledge as a neglected object. It sits near the center of multiple unresolved questions. And that may be the most powerful reversal in the entire narrative. The least protected planet becomes one of the richest in exposed meaning. The least visually generous planet becomes one of the most scientifically rewarding. The world hardest to approach becomes one of the clearest laboratories for understanding planetary limits. Exploration does not civilize Mercury into familiarity. It reveals just how much of planetary history can be concentrated into one scarred sphere near the Sun. This is the deeper revelation Section 14 must deliver. Spacecraft do not simply show Mercury to us. They force us to admit that the innermost planet is not a minor opening note in the solar system, but one of its harshest summaries. Formation, impact, stripping, contraction, magnetism, solar interaction, thermal brutality, and hidden persistence all converge there. And once that convergence is visible, the final step becomes unavoidable, because Mercury is no longer just a world to describe. It becomes a meaning to draw out the most exposed major planet in the solar system, and perhaps the clearest reminder that survival without shelter leaves scars that are not incidental to identity, but identical with it. Mercury begins as a small fact and ends as a hard verdict. That is the final transformation this planet forces on the mind. At the opening of the story, Mercury looks almost modest, the smallest major planet, the closest to the Sun, a dark and battered sphere known mostly for speed. It appears to occupy the solar system the way a brief first note occupies a longer piece of music, necessary, but not dominant, important, only because it comes first. That impression does not survive contact with the evidence. The obvious explanation is that Mercury is a minor rocky planet exposed to strong sunlight and ancient impacts. The real explanation is larger and far less comfortable. Mercury is what a world looks like when shelter fails almost completely, and survival must proceed anyway. It is not merely near the Sun. It is a planet that reveals what happens when the ordinary planetary systems of moderation, cushioning, balancing, and forgetting are stripped down to almost nothing. Once that becomes visible, Mercury no longer belongs at the edge of attention. It becomes one of the clearest summaries of planetary cost anywhere in the solar system. Everything on Mercury points back to that truth. Its giant iron core suggests a world shaped by excess metal or catastrophic loss. Perhaps both a planet that seems closer to its own interior than any neighboring terrestrial world has any right to be. Its surface carries the preserved memory of tremendous bombardment, because so little exists to erase what violence leaves behind. Its long scarps and ridges show that the planet does not merely keep old wounds. It continues responding to its own cooling, shrinking inward over billions of years, as though the damage of formation and the cost of endurance never fully separate. Its exosphere is not a protective envelope, but a ghostly sign that the surface is being stripped atom by atom under solar assault. Its temperature extremes are not incidental curiosities. They are the direct expression of a world that receives energy without possessing the systems required to manage it. Its year races by its solar day, drags on, and even the sky can behave in ways that violate ordinary planetary intuition. Its magnetic field, weak but real, reveals that the planet is not fully dead inside, even though almost every external sign encourages that assumption. And its exploration history shows that worlds closest to power are not always easiest to know. Each of these facts matters on its own. Together, they do something stronger. They turn Mercury into a single coherent idea. The smallest terrestrial planet becomes the least protected major world, the one that most clearly exposes what planetary existence looks like when defenses are reduced and consequences remain visible. That is the meaning of the scars. They are not decorative remnants around the edges of the story. They are the story. Mercury is not a world that suffers damage and then returns to some hidden original purity. The damage is its identity, because exposure is its governing condition. This is what finally separates Mercury from the simplified role it is often given. Mars invites questions about lost habitability. Venus invites questions about runaway climate catastrophe. Earth invites questions about life balance and fragility. Mercury asks a colder question. What remains of a rocky world when the usual forms of planetary mercy are mostly absent? No thick atmosphere softens the sun. No broad climate system redistributes the burden. No oceans store and release heat. No active plate network recycles the crust and grants forgetfulness. No great distance weakens the central power of the star. Mercury remains, and the record remains with it. That is why the planet matters philosophically as much as scientifically. It reveals that endurance is not the same as safety, and persistence is not the same as comfort. A world can survive for billions of years and still tell a story not of equilibrium, but of prolonged exposure. In that sense, Mercury becomes more than a planetary case study. It becomes a boundary marker. It shows how far a terrestrial world can be pushed towards darkness and still remain a world rather than debris. How much can be lost before identity collapses? How much punishment can be absorbed before only the stripped essentials remain? And what remains in Mercury's case is enough to be magnificent in a severe way. Not lush, not forgiving, not grand in the theatrical style of ringed giants or storm-laden atmospheres. Magnificent because it is honest. Mercury does not hide process beneath abundance. It exposes process through reduction. It lets formation impact contraction, solar domination, and buried persistence stand close together in plain view. The answer seems clear until the scale becomes visible. Mercury looks like a footnote until the evidence reveals it as a concentrated planetary limit. The story on the surface is a swift little world moving near the Sun. The story underneath is that Mercury is the most exposed major planet in the solar system, and therefore one of the most revealing. It tells us that nearness to power can strip away illusion. It tells us that smallness can conceal depth. It tells us that a planet can be diminished and still remain scientifically immense. Most of all, it tells us that protection is not a decorative feature of worlds. Protection is one of the things that makes worlds gentle enough to become familiar. Remove it, and what remains is Mercury compressed, scarred, thermally divided, magnetically stubborn, battered from above, tightening from below, and still enduring in the blaze. That is why the planet no longer feels like the first small stop in the solar system. It feels like a final warning hidden at the beginning, a world that turns the opening position in the planetary order into a lesson about cost exposure and survival. And once Mercury is seen that way, the question is no longer what kind of small planet it is. The question becomes what its existence says about the wider meaning of worlds of habitability, of protection, and of the narrow conditions under which a planet becomes not merely durable, but sheltered enough to feel whole. Mercury never offers the comfort of balance. That is what lingers after everything else falls away. It is not the hottest planet, not the largest, not the most visually magnificent, not the most famous in the public imagination. And yet, it may be one of the purest planetary truths in the solar system. Strip away thick air, strip away oceans, strip away weather tectonic renewal and the slow mercies that soften surfaces and blur consequences. Move a rocky world close enough to the sun that every weakness is exposed. Then wait. What remains is not elegance. It is Mercury. That is why the planet matters beyond its size. Mercury reveals that a world can survive without becoming gentle. It can endure without becoming stable in the way Earth feels stable. It can remain intact while carrying the visible cost of formation, bombardment, contraction, radiation, and time. Its scars are not interruptions in the story. They are the final form of the story. Its huge core, ghost-thin exosphere, immense thermal swings, distorted day-lingering magnetic field, and preserved surface all point toward the same conclusion. Mercury is a planet shaped by what it lacks as much as by what it is. And in that sense, it becomes more than the first planet from the Sun. It becomes a measure of planetary deprivation. A reminder that habitability, shelter, and environmental moderation are not background details. They are rare gifts. Remove them, and a world does not stop existing. It becomes harder, starker, more revealing. Mercury survives in full view of power. It survives close to the furnace, close to the gravity, close to the stripping light. It survives without much cover. And because it does, it tells the truth with unusual clarity.